Hi, this is Stephen Rauer from Rhett Valley Community College. This is part 2 of part 1. Part 1 of part 1 ended on this slide, and I said I would get back to it later. There actually is another video that shows how this tree is built. So there's another video that shows the creation of the tree with 38, then the adding of 62, then the adding of 11, etc. What this here is picking up on, at this point in time, if this is our binary search tree, and we want to go and we add 7, then this is the process that it will go through. So first we'll start by looking at the root, which is 38. Since 7 is less than 38, we go left. So then we're here, we're looking at 11. And since 7 is less than 11, we go left. And then we look at 5. 7 is greater than 5. We try to go right, but we can't go right. So the new node is going to be created to the right of 5. And so what I have, here is showing the that 7 as had moving down the tree to going to the right of 5. So I just went through there with sort of a high-level description of what the process that would take place. What we have here would be an algorithm. This is pseudocode that can be used for adding a value to the tree. Now, the left part here, the text that is the sort of black colored text, this is the initial pseudocode that I had written. And what happened is over the years, some people got stuck on certain pieces, and so then I added a couple of Java things to the right. So not every line the Java has been given the equivalent of, but some things I have. So kind of like here, if root is null, the Java for that is if root equals null. And then here it has, so if the root is null, root equals new node. Well, the specifics Java for it is root equals new BST node, parentheses, new element, null, null. So the blue that's on the right-hand side has a couple of lines of Java, but not necessarily the whole thing. So this first part right here, when the tree is empty, it establishes the root from the very first thing that calls that's being passed in. If the tree is not empty, then we come to this part right here. And a key thing is that this cursor is being established by pointing to the root. And so the loop that is here is going to be moving that cursor down the tree. We will look at the value that's being added, this new element, and we'll compare it to the data that's at the cursor. Again, this is pseudocode, so compare to has to be used instead of less than or equal, and the data at the cursor, it's cursor get data. But we'll be taking a look at the value that's being added. Is it before the data that's at the cursor? And if it is, we're going to be looking at the left link. If it isn't, we'll be looking at the right link. Whether we're looking left or we're looking right, first we're going to see is that link, either the left or the right, is it null? If it is null, we're going to be creating the node from that direction. So if the left link is null, we create the node on the left. The right link is null, we create the node on the right. Now, in terms of the Java, I didn't give the full part here, but in other words, this line right here would be cursor set left, parentheses, new BST node. Now I went ... That's the same as this piece up here. So that would be in part of this line. But when we're looking either left or right, if the link is not null, we need to move the cursor down the tree. Well, if we're looking at the left and the left is not null, we need to move the cursor down the tree to the left-hand side, cursor equal cursor get left. So this piece right here will move the cursor to the left of the node that we're at, or what currently cursor is. If we're dealing with the right-hand side and we say move cursor down tree, this will go to the right, cursor equal cursor get right. And so this loop will keep going until finally we do place the node somewhere. So we're either going to be placing it to the left or we're going to place it to the right, and we're done. We're going to be done with this part of the loop. Now this pseudocode here isn't showing the closed curly braces with everything, but it's just trying to squeeze this onto the screen. So what, let me jump to this next one. This is going to be, if this is our current tree, and this is going to be stepping through the pseudocode, and the box here is going to be highlighting what line of the pseudocode is done, and then we'll be adding some annotation into here, such as variables that are being established. So is the root null? Well, it's not, because root is pointing to 38. So then we come down here. We're going to create a cursor and assign it to root. So here's cursor is pointing to what the root is pointing to, which is 38. Now it's not represented, but that Boolean done is being set to false. So while not done, which it isn't, we'll compare the new element, which is the 7 that we're adding, to the data at the cursor. Cursor get data is 38. Well, 7 is less than, so we look at the left link, and the left link here, so from cursor's perspective, cursor get left, this link here is not null, so we move the cursor, so cursor equals cursor get left. Well, cursor is currently here right now, cursor get left, so cursor get left would bring us here. Cursor is now going to become this. Now what will happen is not necessarily showing here, is that ends the else of this if, which then control comes down to the close curly brace here for the while, which brings us back to the while. We still haven't set it, so we're going back into the loop, and now we're asking the same thing again. So the new element, which is 7, we're comparing it data at cursor. Cursor get data is 11. 7 is less than 11. So when we get to this part here, is the left link null? It's not null. So we move the cursor. Cursor go cursor get left. Well, cursor is here. Cursor go cursor get left. We'll move it down to here. So cursor is now at 5. And now we come back up here again. Is the new element, which is 7, less than the data at the cursor? It is not. So then we're coming to the else part right here. It's looking at the right link. Well, the right link is null. So then it'll create the new node from the right-hand side. So from cursor, we're going to set the right to be this new node, which is the 7. And then we're done with this. Whoops, I'm sorry, we're done with this. So this here just stepped through the pseudocode for doing an add to the binary search tree. There's no balancing done here. Balancing is addressed somewhere else. There's no balancing that's being done. And the gist behind it is we're always starting at the top. We're always starting at root, and we just keep moving cursor down the tree until we get to where it is that the node needs to be placed. And it'll be placed to the left or the right of a node. And so we just need to find the node where it goes to the left of it or to the right of it, and it is added there. Let me end this video, and so this video is going to be just the add algorithm. Yeah, let's just do that.